Danica, could you turn off the other one? There we go, thank you. Okay, so here we are, log regressions. Okay. So at the end of this lesson, I will also assign a couple of pages for you to keep trying, especially the decreasing functions. 46 we are right now. So modeling means regressions, okay? We're trying to model the curve of best fit. So when we perform regressions, listen up, yeah? Our calculator can only do a natural log regression. We cannot do the log, okay? But it doesn't change anything. It's the not the linear, natural log regression you want to access. Please do not mix up linear regressions with ln regressions. Please don't mix that up. It's a completely different function, okay? So when you state your equation, you should always use this format. When you state it, basically just follow what the calculator is doing, okay? What it spits out. All right, so here we go. The flash on most digital cameras, they used to be cameras, guys. Now we use phones, right? Mostly. Requires a charged capacitor in order to operate. The percentage charge, Q, remaining in the capacitor was recorded at different times, which is T, after the flash has gone off. The T5 flash duration represents the time until a capacitor has only 50% of its initial charge. The T5 flash duration also represents the length of time that the flash is effective. This is a very nerdy question, I know. To ensure that the object being photographed is properly lit. So depending on, how much light is required, that's how much light will be produced by this capacitor. So construct a scatter plot for the given data. So let's type this in. So when you have a table, of course, we're going to go L1, L2. So the first one is X, correct? Second one is Y. Where's time going to be, guys? Time is going to be on my y-axis, okay? So let's go ahead and type this into our calculator. I would invite everybody to do that because it's tricky to make this show up on our screen. So here we go, 100, 90.26, 73.9. And double check that you type this in right. Take the extra second on the exam, on the test, take an extra few seconds and check. And then you go to the next one. 0.01. There we go. How do you do a scatter plot? You got to go to Y. You got to turn on plot 1, clear all the equations you have in there. And as soon as plot 1 is turned on, you can go zoom and then zoom stat. And there it is. Can this be an exponential function? What is this here? 100, 0. What would that be in our case? The x-intercept? Does an exponential function have an x-intercept? No. So that it rules it out. But here are the good news, folks. I just emailed the province yesterday because I wanted to make sure. I thought that's what they said. I asked them, are you always going to tell students what regression to perform? Whether it's quadratic, cubic, log, exponential? And they said yes. They will always tell us which one to use. I still want you to be prepared to answer a question as to why can this function not be, why can this not be an exponential? I would expect you to say, oh, it has an x-intercept, can't be, because that's the asymptote, right? It just never touches it. So that's why I still like you to look at the scatter plot or look at the points themselves. So we've done the scatter plot. Let's just make a little, a little scatter plot, no big deal. There we go. Determine the logarithmic model for this data set. So we're going to go stat, calc, and we're going to select natural log regression. So stat, calculate, and natural log is right here. I don't like that they put linear regression right next to that one, but you got to be careful. Pick that one. And then just feed it L1, L2, comma, alpha trace, as always. Everything else is the same. And there you have it. Let's write it down. 0.46 minus 0. You know what I'm going to do here is I'm going to go 4 decimals. Because I just for kicks, you would not lose marks if you put 0.1, because that's normally what it is. But remember, we pasted this whole thing into our y1. So let's graph it and see what it looks like. Beautiful. I would say I want to make sure my window includes the y-axis, so I'm just going to go check. X min, notice that it is 34. I'm going to go -5 for my x min, and then hit graph again. That's better, I see it. I'm still going to chase the curve up a little bit. It's never going to touch the y-axis, right? I'm aware of that, but I'm going to go y max and maybe go, look at how small y max is already. It's tiny. So if we go 1, it's probably going to do it. Right? 1 is probably even overkill, but at least, and it never touches, even though you might think it does, it doesn't. Okay? So use your logarithmic model to determine the T5 flash duration during to the nearest 100th of a second. What's going on here? Let's make sure we understand. Every x is percent charge, and this is time in seconds. Okay? We know that because that's what we've typed into our calculator. What is this giving me? What's T5? Logarithm, the duration. It is, let's read here what T5 means. T5 represents the time until a capacitor has only 50% of its initial charge. So basically they're saying figure out the time when you only have 50% of the charge left. Like how long would that take? That's basically what I'm asking you to do there. So how do we do that? Second, trace, value, and x is equal to 50. And how do I know I can use 50 and not 0.5? Because I go up here and everything is as a percent, right? These are percentages, so no need to divide by 100 to get this. So let's figure that out. Second, trace value 50, and there it is. Y is 0.07 essentially, and that is in seconds. And voila, you're done. Okay. What's our time like? Okay. I'm gonna add one here that you're gonna love, domain and range. See, I can sense it already. State the domain and range. State the domain and range. And we're gonna make a little sketch. If you don't graph this thing, please do this for yourselves, okay? This is time, and this is Q. That's the percentage, right? Charge. We know that 100 is part of it, okay? So we're going to go from there, and we know this is a decreasing function. Our calculator tells us that. It will never asymptote. Think of Lord of the Rings, if you've ever watched Lord of the Rings. You shall not pass. You know, when that scene, you shall not pass. Think of this being, you shall not pass. The curve will just never pass that. I used to have a shirt that it said asymptote, you shall not pass, and the whole scene there, it's pretty cool.
Right.
Yeah, I did. I don't have it anymore. Yeah, I don't have it anymore. I don't know what happened to it. What would be my domain here? So off track, right? Stay on task, Mr. Dukes. We're thinking domain x values, right? What's my lowest x value I can possibly have? Like, how far? What do you think? 0, right? 0, but it will never touch, so round bracket. And what's the greatest x value I ever get to? The greatest x value? 100. Can I include that one? Yeah, it's right on there, so sure. What about range? The lowest y value is 0, yes? And the highest? Infinity. Yes. There we go. That's how you would do the domain and range in this scenario. Okay? I'm going to stop here. Otherwise, you're going to probably kick me out of my class. Hold on. I'm going to ask you to do, I have an AC that I wanted sent home. So I'm going to rather do that. So for now, homework is just take home AC. One AC, one question on this stuff. I'm going to post a few of these types if you need to look it up, if you need to try one or two more on your own.